Hello everyone, and welcome to Sky Observers Hangout. Thank you so much for joining us tonight. You know, I'm not typically the one doing this part of the introductions. It's kind of throwing me off a little bit. Thank you so much for joining us this evening. Your usual host introducing us is Michelle Nichols, right back here, Director of Public Observing here at the Adler Planetarium. I am Hunter, Public Observing Educator here at the Planetarium. And we've also got some friends helping us behind the scenes this evening. If you see the Adler Planetarium's name in the chat, that is our colleague Bella. She will be feeding us any questions that you have this evening. So let us know if you have any thoughts while you're watching tonight, any questions for us, and we will be happy to answer those. If you also see Geza in the chat, Star Geza, our astronomer colleague, he will be answering those extra hard-hitting questions tonight that we need a little extra help with, because I know sometimes questions like that be coming through for me, definitely. So a huge shout out to both of them for helping us out online tonight. We also have Dylan here behind the boards. I realized when I pointed that way, it looks like I'm pointing to who's sitting right next to me. He is not our producer this evening, but is a very special guest today. So we are also joined by Nick Lake. Nick, do you want to introduce yourself a little bit?
Sure, yeah, my name is Nick. You might recognize me from a few things, maybe some of the Adler content of Skywatch Wednesday. You might have seen me present a show or two at the Planetarium. I'm a manager of theaters here at Adler, and I also have a YouTube channel, the Windy City Astrophotography, so you can check that out as well.
So that might give you a little bit of a hint of why we've got Nick on the show this evening. He will be our content expert today, bringing us all of the exciting astrophotography information tonight. I know this is something that lots of people frequently ask us about online, so it's great to have such an expert. If anybody's ever seen his YouTube channel, you'll know that he pulls off some pretty awesome stuff, and you'll get to see some of those exciting images tonight. Now, before we get into the show, I wanted to give a few mentions. If you are interested in coming and visiting us at the Adler, that is where we are here tonight. We're out back behind the planetarium in the Doane Observatory. Bella's going to post a link in the chat with a link to where you can buy tickets to come and visit us. If you want to come look through the observatory telescope behind us, any clear Wednesday night, we are also out here, and you can come and look through yourself, not with a camera or anything hooked up, with an eyepiece in those situations. So we would love to have you come and visit. If you're joining us from a little further away, which I already see somebody's joining from Hamilton, Ontario tonight, then you are welcome to subscribe to the channel down below so that you can stay up to date on all of Adler's content. Like Nick mentioned earlier, that extends far beyond just Sky Observers Hangout, these live streams, but also lots of other great content, monthly sky watching videos, letting you know what's up in the sky for that season. Wow Signal, great space comedy show, which I gotta say, the most recent episode is a great one, not just because me and Nick are in it, but partially because me and Nick are in it, of course.
The start of the show, right?
I don't know, your acting was pretty spectacular. You gotta see it, you gotta see it. It's the one about cheese, that's the one that has us in it. So hit subscribe down below if you're interested in seeing more content like this. And I see a few of you are already doing this. We told you where we were joining you from today here in the Doane Observatory. We would also love to hear where you all are joining from today. We'd love to hear from you, and that always is a great way to get the conversation started. So far I see some people in Hamilton, Ontario, somebody in Mokina, Illinois. So thank you for joining us. Love seeing the local and more distant guests here tonight. All right, well, while Michelle is still working a little bit with our telescope setup this evening.
So you're probably wondering why I'm back here and not saying hello, everybody. It's because it only cleared up here about 3 minutes before we started the show. So we have not even had a chance to fully focus the telescope, let alone find anything. So that's what I'm doing. So I'm turning it over to the capable hands of Hunter and Nick. So that's what I'm doing back here. So
yes,
we'll get back to you in a little bit.
Any of you who've visited or have come to Sky Observers Hangout before, you know Michelle's the telescope expert. I get my nice comfy seat here right in front of the camera, and she takes care of the tough stuff during the show. Oh, one more person joining, currently in Chicago, but soon to be Salt Lake City. Hope that's an exciting move. Congrats on the move. Hope things are going well. Now, talking a little bit about what this show is going to focus on tonight. So you can see from the title, we're calling this one Astrophotography 101. So we're going to be doing a little primer on astrophotography, what that means, and of course, just like we always love to do, giving you practical tips on some of the things that you can do with astrophotography, from right at home all the way up to how we take pictures through a big telescope like this in an observatory, and extending all the way even to, you know, similar techniques being used for major scientific research all across the world today. So to start off tonight, we want to talk a little bit about, you know, well, why we asked you to come on today, Nick, as our special guest host. I mean, one, we love you, you're a great colleague, but also you have quite a background in astrophotography beyond being, you know, just running the theaters here at the Adler. So tell us a little bit about like your background and how you got started.
Sure, yeah, so I've been at Adler for almost 21 years at this point. And way back when, we're looking at a great image of me long ago with long sideburns.
Oh, you mentioned him before I did. Oh, I was waiting to call him out. I didn't do it during the dry run, so I could catch you by surprise here today.
So this was, the summer that I started at Adler. I was still a student up at Northwestern. And I used some money from my first few Adler paychecks to buy that telescope that you see there. It's an 8-inch reflector. From Orion telescopes, and I still use that today. It's a great telescope. But something that I started doing once I had this telescope that I was really interested in was astrophotography. And at the time, this was quite a while ago, a couple decades ago, I was using film to do that. Digital cameras were around, but prohibitively expensive, especially for somebody still in college. So I used a film camera that my dad had, and I bought the film. I would try and take some images, and then take them to the Photoshop, and they would develop them, and I'd get them back a week later, whenever I could get to it, and kind of see what happened. And I will say that we're not going to talk a lot about film. That is one of the limitations of that medium, especially for astrophotography, and I guess photography in general. You don't see what you got until much later. So you really had to think ahead about what you were doing, and the results were somewhat mixed. We can see some images here. The moon is pretty easy to do. We'll be talking about that a few times during the show. Very short exposures. You don't need a whole lot of good equipment necessarily to get good images there. But for some of the things like stars and clusters and galaxies, you need a mount that's able to track the sky. At least to a certain degree. So a couple images there. The top center is the constellation of Cassiopeia. That was taken actually without the telescope. It was just using, it was a camera kind of like this one. This is digital. It was a film camera. I was also able, for the moon shot, with a lot of these digital cameras, you can remove the lens and then stick this directly to the telescope. It's called prime focus astrophotography. It turns the telescope into kind of a telephoto lens. So that, think about it, it's a 1,000 millimeter, it's a meter long focal length on a telescope. So it's like getting a 1,000 millimeter lens on there. So pretty big lens, zooms in really well, and you get some good results. But you need very accurate tracking for that to work, which I didn't really have at the time. But I was able to get some decent images with the film. But that was kind of the beginning of it, and then since then it's been kind of a journey, like, okay, what kind of pushing up against the boundaries of what I can do with the equipment I have. What else could I get? How can I challenge myself a little bit more to take some more beautiful images of the universe?
And I know, over my last couple of years working here at the Adler and talking to so many professional and amateur astronomers, I know that can be a slippery slope. You start taking pictures and you get into it, and now, oh man, then the gear comes. And I've seen some of the gear collections of folks, so I'm excited to talk about some of your more updated gear that you have later too. Now, I think this is something that, a lot of folks assume when they hear that we work at the Adler, that we do a lot of these things in our free time, but it is different to, it's not the case for all of us,
That's true.
And so seeing, your passion for it and the incredible images that you're able to pull is really cool.
Thank you.
We love being able to see them here at the Adler. Now, It's great to hear your story, but I know one thing that and actually I want to give a shout out to a couple of other people because we've got some pretty far away viewers joining tonight. Somebody was mentioning that they were watching from Saudi Arabia, recently moved from Chicago, so previously visited the Adler, missed the Adler. Well, we can't wait to see you come back and visit soon as well. And then also some folks joining from Downers Grove this evening. Don't remember, you're also welcome to post any questions you have in the chat tonight.
Yes, please.
Now, one thing that's really funny. Somebody said sea stars are a gateway drug. Well, we'll actually be talking about that later. We will be mentioning, we've got a sea star set up right now. Honestly, Dylan, if you want to switch over to the sea star view quick, we don't have anything interesting in view yet. This is what I was using as our first target for the night, is a little view of Arcturus here, that bright star that you see there in the middle. So yeah, we'll be getting into the sea star a little later. But before we get to yes.
And actually, I've got Arcturus through the big scope too. It's also not terribly exciting. It is there. It's a little bit off to the side, but it is there. But would you like me to move the telescope to our target? Because if so, I'm going to have to move the roof.
Yeah, sure. We might as well give it a shot. We're at a good point. So while we are talking about astrophotography, and we'll be looking at a lot of pictures that were taken in the past that have already been processed and things, gone through a lot of that work. And you can also see the telescope moving behind us to our new target for tonight.
Yep.
We always love to provide live views as best we can as well. And well, part of that involves getting them set up in advance, which we were not able to do so much tonight because of the weather.
Yeah, but it's clear, which is more than we had for a Wednesday night for a long time.
Yeah, exactly.
So I'm going to move the roof. It's going to be loud and squeaky, so you're going to hear us. Actually, you're not going to hear us because we've got to turn the microphone down. So give me just a second. All right, 1, 2, 3.
All right, we're back. Sorry, everybody.
A little bit more.
Oh, a little bit more. Sorry.
Okay.
So the telescope that we have here in the Doane Observatory was just installed in 2020. It's only 5 years old. Very nice and quiet, moves really easily and smoothly. Roof, a little bit old there. That's from 1977. So anybody that has come out to the observatory and visited before knows how loud and squeaky it can be. It's powered by go-kart tires, which I always like to point out, which is impressive for the fact that it's moving a huge metal roof in a circle. The marvels of an observatory extend beyond just the sky. Sometimes it's the technology that makes it possible. So our main target that we're hoping to look at live tonight is a galaxy, Messier 101, the Pinwheel Galaxy. So this is a target 21 million light years away, and galaxies like these are, I think, really exemplify the perks of astrophotography, right? When you look at something like a near Earth object, things that are in our solar system, like the moon or other planets, through the eyepiece, there's so much detail, such an exciting sight to see. That can be a little different when we're visually observing some of these more distant targets. And I think that's something that it can be surprising for people a lot of the times when we look at these deep space objects, things outside of our galaxy even, right? Is that, they're really far away. They're very bright objects if you're close by. But like I said, this light is traveling, over 20 million light years to get here. And so they can be pretty dim through the eyepiece. But this is where the benefits of astrophotography really come into play. And we start to see the advantage of larger lenses that we're using, stacking images like the sea star is doing, taking long exposures. We'll get into all of the meat and potatoes of that later. But some of these techniques really do make a big difference. Ooh, good question, and it's a big answer and kind of really what the topic of the show will be tonight. But somebody said maybe a silly question, and I want to start by saying it absolutely is not a silly question. It's actually a smart enough question that we decided to do a whole show about it. How do you get the photos of stars and nebulas that are super colorful and look very close up? I'm guessing those aren't taken from the ground. So really good question. So some of them may not have been taken from the ground. We do have some space telescopes out there like the Hubble or the JWST that was recently launched. And those can get, even more detailed views because they're not limited by our atmosphere. But even with equipment here on Earth that is reasonably accessible to the everyday person, that anybody can go out and purchase. You don't need a telescope like this to get a lot of those images that you've seen. And so as we progress through the show tonight, you'll see a lot of Nick's images that he's taken, and you can see that it really is doable from here on Earth, but it requires a lot of tricky techniques that make that possible. So I don't know if you want to talk about that at all, like the super colorful images of the nebulae and how they look so quote unquote close up, right?
Yeah.
I think that there's a lot of interesting points to think about here.
Yeah, I think one of the things that surprised me when I started looking at some of the deep space objects was how big they actually are in the sky. So you think about something like the Andromeda Galaxy.
It's always my favorite example.
We can see a little bit of it with the naked eye, just a little smudge in a very dark sky. And yeah, if we want to bring up an image that we have later on. So what you can see with the naked eye is the very center of what you're looking at there.
Right. And important note, with the naked eye, from a very dark location. It's pretty near the limit of our naked eye.
Yeah. But the full extent of this image, and this is like one frame from the astrophotography rig that I usually use, if you were to take an image of the full moon, you could put 6 full moons across the diagonal of this image, and that's how big it is in the sky. I mean, it's just crazy to think about.
Right. So a lot of these objects
huge looming objects.
Right. They're incredibly far away, which they're huge objects, so they're still big in the sky. But our eyes just aren't sensitive enough to the light that they're emitting. Right. It's very dim levels of light, and so you'd be surprised at how many of these are actually quite large. And there's a lot of targets where we actually, like with a telescope like this that has a very, very tight field of view, we can be limited on some of the objects we look at. And actually, a lot of the images that you shared before are things that we typically don't image with this telescope because the field of view really is too small for a lot of these kinds of things. So I think that is something that often really surprises people. And then we'll get into some of the details of the colors and things later. It requires a lot of different filters, some of them even being, very particular wavelengths of light that are emitted by certain things out in space. So we get into a lot of detail work that is what makes astrophotography honestly so complex. A lot of it is not, done while imaging. A lot of it is that post-processing work. It's a lot of work at a computer at the desk afterwards, right? And we'll see some of the pictures later on in the show.
That's a great question.
Yeah, it is. No, it really is like a lot of what the episode will be about. Another question we had here is, how frequently are astrophotographers finding new things in the sky, and how do they communicate their findings? That's a really good one. I will say that astronomy, I feel, is like a field of science where there is still so much to learn that it is a place where amateurs can make big discoveries. And actually, if you were at our supernova show last fall, when was that from?
It was about 2 years ago.
Was that 2 years ago?
Yeah.
Oh my goodness. Well, we did a show, the title of the episode maybe was Gazing at Galaxies or something. We had a show planned about observing some galaxies that night, and like a week or week and a half prior to that, a supernova occurred in M51, the Whirlpool Galaxy, and that was discovered by, he is an amateur astronomer, he's a very prolific amateur astronomer from Japan that is known for hunting for these supernovae. And so, the sky is changing, and these kinds of things are what can be found by amateurs.
Yeah, so it depends on what the object is as to where you report it. Yeah. So basically, amateurs would report their findings to where exactly the professionals would do it too. So if there is a new asteroid, or a suspected new asteroid or new comet, they would report that to the Minor Planet Center, which I think is run out of Harvard, one of the Eastern colleges. So the Minor Planet Center collects all the details related to all of that. If it's something related to a variable star, a star that changes in brightness, you might report that to the American Association of Variable Star Observers. And so there's a lot of databases and people who collect different things. There's no one central repository for this information. It just depends on what it is you may have found, and that would be where you report it to. Great question.
Yeah, it is a great question. And a lot of these databases are like just publicly available online. You can see these things. It's a big database of a bunch of values. I think it's not really that thrilling, if I'm going to be honest. But there are a lot of things, these kinds of transient objects, things that are not always there in the sky, but are just temporary, like a supernova, like maybe a new asteroid. There are still some amateurs that discover some of these things. That'll get more difficult as we have these more detailed all-sky surveys constantly happening of the night sky by professional observatories, research observatories. Oh, so many good questions coming in. Thank you for all the wonderful questions, guys. This is really great. We're having trouble even keeping up with them, so keep them coming in. They're really wonderful so far. Somebody said they're going up to rural Wisconsin this weekend, hoping for clear skies. I've done the moon and some planets. Want to check out galaxies. What are good options? Okay, so I will take it that this person does have a telescope, I would assume.
Yeah.
Andromeda is the one other galaxy that you can see with the naked eye, but what would you recommend for this time of year? Have you been doing any imaging lately?
This is the time of the year to do it. Yeah, so a lot of the imaging I do is narrowband, which sort of in broad terms is very specific wavelengths of light, which doesn't work great for galaxies. I do most of my imaging from the city of Chicago. But this time of the year, a couple of the other objects I would recommend would be kind of all around the Big Dipper. So we got M101, the Pinwheel Galaxy, which we're going to be imaging here. You've also got the Whirlpool Galaxy, M51. And then there's two, M81 and M82. That's a very close pairing. All of these are visible, even with binoculars, if you're in a dark sky and you kind of know where to look. I would recommend finding a good star chart that's a little bit detailed of the area kind of around the Big Dipper, and just go to town on it. You should be able to star hop to each of these, and then with a good telescope. You may not get a lot of structure that you're seeing, like in some of the images. We could maybe pull up an image of the Whirlpool Galaxy that I've taken. In that case, you're seeing way more detail here than you would ever see in even a single exposure from a telescope, much less with the naked eye, or with a telescope view through an eyepiece. But you would be able to, with some patience at the eyepiece, spending a lot of time looking at it, be able to discern a little bit of the structure.
Right. So actually, honestly, a pretty good example of what you might kind of see is in the C-star view right now. We do have the Whirlpool Galaxy, or sorry, Pinwheel Galaxy starting to build up the image here. Let me zoom in a little bit. So this will continue to build up over time, and we're getting a little bit ahead of ourselves here, but I'll go into some details. So the C-star, which someone mentioned earlier as like this kind of beginner jumping off point into more complex astrophotography, the C-star is kind of under this new genre of telescopes, these smart telescopes. So the C-star S50 is the one that we're using tonight. They also have the S30. Those are indicative of the size of the lens on the front of the telescope, right? So it's a 50 millimeter lens. It will take many long-ish exposures. This one does 10-second exposures right now that we have it set for, and it stacks those together over time. So you'll see right now, not a great view of the galaxy. It's kind of a faint smudge, and that's how a lot of these deep sky objects are often described, is right, these faint smudges in the sky. And as it continues to build up that image over time, you'll see really the benefits of post-processing. And this is a quick and easy way to do it. You get a much better view when you do more complex post-processing like you do with your images. But this is a great jumping off point, and is doing this totally live on its own, right? So this doesn't require any work. So these are some other images that we've taken through the C-star. Of course, it still works with some of those brighter targets like the sun and the moon that you see here. We also have some of those dimmer targets here. So up in the top left, the Andromeda Galaxy, you can see does not quite compare to the view that you got with your telescope. But then also, some other ones that can be pretty dim. The Veil Nebula here in the center on the bottom, even starting to pick up some of those red and blue colors that you can see in that nebula, as well as some planetary nebula, the Dumbbell Nebula in the top right corner and the Ring Nebula in the center there. So, if I'm going to be totally honest, before we got the C-star, I was a little skeptical. I wasn't sure how good of a job they would do. I was really pretty convinced right after our first use. As an entry point for getting into astrophotography, if it's something you really do want to commit to, it can be a great way to start you off and begin to learn the sky and some of the processes that are happening without having to do all of that complicated computer work.
I would agree, yeah.
I need to move the roof again.
Okay, no problem. Thank you.
All right, give me a sec. 1, 2, 3.
So we
Wait,
get
a little bit more.
a little bit more. Sorry. So somebody left a comment. They said sea star is the best thing to happen to astronomy / astrophotography since Galileo. Wow, I mean that's going far back. Simply brilliant scope. I will say, I mean it does do impressive things. The only thing I'll say is that there's something special about visual observing. I mean it's unfair because that's my job is doing visual observing, but there is something special about seeing it through the eyepiece. And while it may not look quite like the astrophotography views, those astro images, it's knowing that light traveled over 20 million light years, and those photons of light were unimpeded until they hit the back of your eyeball, and that's the end of their journey. That's it right there.
That's special. Yeah, yeah, I would agree. I don't think astrophotography takes away anything from the visual observing. Obviously, it's a better image, but I mean, there's just something so satisfying about star hopping to one of these dim fuzzies and seeing it through the eyepiece.
Right.
And then over time, getting familiar with it, your eye starts to kind of build up an image as you stare at it through a telescope. You start to see more detail, and it's kind of a discipline that you have with this observing that, I don't know, it's very satisfying to do. So I definitely
There definitely is a lot of skill
don't
involved.
give up.
No, absolutely.
Yeah, yeah, definitely.
Michelle's got a new live view. Is this which cluster is this?
This is M13, the Hercules cluster. I figured if you were showing M101 through the sea star, I figured I'd go to something a little different. So
yeah, so another one of those, deep sky objects that can be, the globular clusters, there's enough contrast that they're pretty easy to see through the eyepiece. I think they're pretty stunning views. But these big clusters that sit just outside of the plane of the plane of the Milky Way galaxy, almost like little dwarf galaxies that orbit around it that contain, hundreds of thousands of stars, and they're always a dazzling view. Okay, now we got a little bit ahead of the simplest form of astrophotography. We jumped ahead to the sea star, and I'm excited to continue kind of keeping up to date with those views throughout the night as it continues to build that image up. But we always like to give the most practical tips that we can for everybody at home, right? And we know that astrophotography can be, it can be pricey. It's certainly an expensive hobby, depending on how far you get into it. And so we always want to give tips for folks that are just using the things that they have at home as well, right? So I think the easiest place to start with that is people's smartphones, right?
Absolutely.
So what kind of tips do you have for folks using their phones at home to image the night sky?
The phone is a great place to start. It doesn't really matter what kind of phone you have. Any modern smartphone is going to do a decent job with this. I have a Pixel phone. I've also used Samsung and iPhones as well for astrophotography. Those three particularly have a sort of an astrophotography setting that may go by different names depending on the phone. But essentially, if you're in a dark enough view for the camera and the camera is still enough, the phone is still, you're not holding it in your hand, it'll switch over to a mode where it's going to start looking for stars and taking a longer exposure, sometimes up to 2 to 4 minutes, depending on the model of phone you might have. There's some images here that I've taken with a phone very much like this. The one thing I do recommend, if you're able to, if you already have like a camera tripod at home, that's a good start, but you can get a smartphone adapter for it, where you just stick the phone in here, and that's able to keep it nice and still. You can also use other things. You can just lean it against something, or maybe on top of a car, have it leaning against a water bottle, looking up at the sky. Now,
I know a lot of people will put their phone face down on a surface and just do an image straight up of the sky for these big wide views.
Absolutely. Yeah, so it's going to be very wide. This is good for Milky Way shots or like full constellation shots. This is an image here that I took down Middle Fork River Forest Preserve, which is about 2 hours south of the city here. Obviously, my big telescope there was doing some imaging with the DSLR, but with the smartphone, I was able to get this image of Orion, which is what the telescope is pointed at the Horsehead Nebula. So the phone, it's kind of doing what the sea star is doing as well. It's taking a series of shorter images and then stacking them on top of each other. This stacking thing that can happen automatically, or it can be done manually in a piece of software that you have on your computer. What that does is it builds up what we call the signal, the part of the image that you want to see, and it gets rid of, or at least lessens, the noise. So every electronic device, digital camera, things like that, you can have noise. You can have just random bits of fluctuation in the image. And you can see...
Which you can actually see, quite a bit of that in the sea star image, like see in these dark sky areas of the sky.
Kind of blotchy.
Now, as you especially get it here on where the field rotation is up on the corner of the sea star image.
Yeah, so as that image builds up, that's going to go away, and the galaxy itself is going to get brighter. And it's something where essentially the camera and the software is able to recognize, okay, these things are remaining the same every time that star is right there, every time this arm of the galaxy is right here. Okay, let's keep those, and let's lessen the stuff that's changing every time. Now that could get rid of camera noise. It can get rid of airplane trails. It can get rid of satellite trails. It can get rid of little cosmic ray hits that you might get on your sensor, which actually happens more than you'd think. These weird little squiggles on the image.
For folks that have been to Sky Observers Hangout before, you've seen like the donut ring that's caused by dust somewhere.
Yes.
Maybe we think in the camera, but it could be in the telescope somewhere too. And one thing I will add for doing, astrophotography on your phone is that I think the first thing that a lot of people want to take pictures of is always the moon. And it totally makes sense. You look at it with your eyes and it's so big and bright in the sky. We'll get into details on this picture of the moon. But you take a picture with your phone and it will look really small. And you start to realize like, wow, it really doesn't take up that much of the sky, but it is so brilliant for our eyes to see. So, taking these big wide field views of the sky is really what it excels at, and seeing stars that your eyes aren't going to see, right? This much more detailed view of the sky than what your eyes is going to pick up. Now, you did take this with your smartphone. Tell us a little bit about how these images were taken, and this actually goes into a question somebody had in the chat here.
I mean, it looks like I was in orbit around the moon or something here. This was taken with the 1,000mm focal length reflector. There's a different type of smartphone adapter that you can get, which wouldn't go on a tripod, but it would actually attach to the eyepiece that's on the telescope itself. So instead of your eye being there, it's the phone's camera looking into the eyepiece and then taking an image. Like this. It's also great for kind of visual observing of mainly the moon, but possibly the planets as well, because a lot of people can see the phone screen at the same time. As long as you're not in a dark sky, trying to maintain dark adaptation. It's a fantastic way to have a lot of people looking at the same thing through the eyepiece.
And it definitely excels at with pictures of the moon. It's such a big, bright object that it really helps a lot. Yeah. And if you've ever been out to Wednesday nights here at the Doane Observatory, you may have gotten a little keepsake photo to take home with you. One of our volunteers, when the moon's up here on Wednesday nights, is always taking pictures. He's got to be up to thousands of phones that he's taken moon pictures with at this point. So if you ever want one of those, come out here on a Wednesday night where we've got the moon up, and you can take home a Lunapic on your phone as well. So we had a question in the chat, somebody wondering if anyone ever tried stacking images using a Dobsonian telescope and a phone camera. So that is the exact kind of setup that we are using when we are taking images of the moon out here. Does get a little tricky when it comes to stacking images because the tracking and keeping that exact same field of view is very important. One thing I have seen some people do with that style of telescope is taking videos while things are passing over the field of view and then using those to stack images together. But it can be a little tricky when you're using a manual telescope and doing astrophotography. Having tracking is really pretty essential for a lot of the kinds of pictures we're taking.
One of the things that a telescope that we have, or like Nick has, it's tracking and only moving essentially in one direction. With a Dobsonian telescope, it moves up and sideways, and so you have to move it in two directions to be able to keep whatever it is in view. It's not impossible, but it's really hard. But yeah, taking video might be an option possibly if it's a short video, and then because your telescope probably isn't tracking, because sometimes if you're going to add tracking to a Dob type telescope, you're going to spend more for the motors than you will for the telescope. But it can be done. but you may, if you take a video, you might end up having to cut out the edges of it and only use maybe what's in the middle.
Right.
So that might help.
Yeah, there will be a couple images later on that it's not with a phone camera, but with a DSLR and hand-tracked telescope, similar to a Dobsonian. You can do it with a Dob pretty easily. So it's possible, but not the easiest. So.
But that doesn't mean they shouldn't try it.
No,
maybe it's a challenge. We've given you a challenge. I did get our telescope really centered on M13, so there you go,
lovely.
really pretty. This is an unprocessed image. This is an image that is just over 41 seconds in terms of exposure time. So you can see a lot of stars. Actually, I'm going to adjust the zoom just so you can see it a little better.
Yeah, so we'll start to get into some of these details of like some of the different settings we're working with for all of these to make this possible, right? There is our exposure time, there's our gain, then you get into the details of using different filters. I did want to get to a couple of questions that we had as well while we have this lovely telescope view here on the stream. Wanted to make sure it hadn't been too long since we answered them. So one person asked, have we seen improvement with the sea stars now that you can take flats and use equatorial mode? Very good question.
Wow.
I have not experimented with either of these yet, I will say. One thing that I imagine the equatorial mode probably does help with a bit, I haven't gotten too into the details of this. I would assume that it would have to be on a different kind of mountain than what it default comes with to be able to utilize equatorial mode, but that can help with some of this like the rotation issues that we're seeing. So if I zoom in up here on this corner, you'll see that we have a lot more noise up here. That is because this object is moving in the sky, right? Moving in the sky as the Earth rotates. It is, just as Michelle was saying with the Dobsonian style telescopes earlier, moving up and over, up and over. So as things get to these higher points in the sky, it is rotating a little bit. If you go out at the beginning of the night and see the moon in one side of the sky, and then go out and see it on the other side of the sky at the end of the night, it will have rotated, appearance for you. And so I'm sure the equatorial mode can help with that. I haven't done any taking flats with the sea star yet, so I can't say that I have much experience, but certainly that would make a difference because those are very, very essential to post-processing in astrophotography.
Yeah, it's going to help you get rid of any dust rings or anything like that in the image stream.
And if our viewer from Mokina if it's the person who we think it is watching from Mokina, we know that particular person has a lot of experience with the sea star, so maybe he might be able to help out.
I think we could say his name. Bob, you used the flats or equatorial mode yet?
Bob is one of our telescope volunteers, and he actually has done a lot with his sea star. So if he has that answer and can help out, Bob, if you're still watching, if you could answer that'd be really great.
We haven't had a lot of clear nights in Chicago recently to do much experimenting.
No, we're actually pretty shocked it's clear tonight, but it seems like Sky Observers Hangout this year, we've had clear nights.
We have been really lucky so far. So another question that we got in the chat was, somebody said they were really new to astrophotography. Something that they had been seeing a lot, and something you may have been noticing watching the stream so far as well, is what exactly are monochrome cameras, and why do people prefer them over color cameras in astrophotography?
Great question. So pretty much any color camera you have, it's actually a monochrome sensor in there, so it only takes in light. But what it has on top of the monochrome sensor is called a Bayer matrix. So for every 4 pixels, little tiny bits of the image, there is a red filter, a blue filter, and 2 green filters. Our eyes are more sensitive to green light. That tends to be how our brains interpret the world. We're just taking in a lot more green light and we're sensitive to it. So that's what we see as a correct color on images. Modern smartphones, digital cameras are going to be doing some extra processing before you actually see the image that's been taken. But in general, what's happening there is the light is passing through a filter before the image is actually taken. The reason monochrome is useful is if you are, this is specifically for narrowband astrophotography, which I do a lot of, but it also applies to just broadband, like taking pictures of galaxies. If you were to take an image of the Andromeda Galaxy, let's say, and you have red, green, and blue filters, if you were to put those filters on your telescope and then use a color camera, you're getting so little of the actual data. If it's a red filter, you're getting 1/4 of the actual light that's coming in is actually being processed as red light. If it's green, you're getting about half, and if it's blue, it's about 25%. So you're not getting as much data as if you used a monochrome camera, and you're getting everything you're getting there is the red light, is the blue light, is the green light. It's going to look gray as you're taking it, but then when you're processing, you're assigning, you're saying, okay, this is blue, this is green, this is red in the software, and then all of a sudden it looks correct. That's something your camera is kind of doing anyway in the background when you take images. So,
as a matter of fact, what the image that you're looking at right now, this is the monochrome camera that we have attached to the telescope. So I think
Get
you
my
can see
head
it.
out of the
it's
way
right there.
enough.
So that red thing that's sticking out, and it's got a filter wheel attached to it. So we have our camera and our filter wheel. Except that his camera
Very
is
similar.
just like ours, only just slightly different size.
Yep.
And then the filter wheel is attached to it, and so we can change the filter that the light passes through into the camera. So if you look at the image that we've got, look on the lower right-hand corner of this particular image, and you'll see where it says scope controls, if you can see that level of detail on whatever you're watching us on, where it says B and G and R, those are filters. And so right now I've got as much light coming into the camera as possible. I have this set at a space that has no filter. So if I move the filter and then take another image, or move to one of the color filters, you might see that the image might look a little bit different. So these are 41-second images, so I'm going to do that because we've never done that before with
I don't
this.
think we've ever done that during a show. Yeah, we've never messed with the filter wheel
No,
before.
we've never messed with the
No.
filter wheel, so why don't I do that and I'll see what it looks like. All right.
Yeah.
Yeah, and I think one other detail I wanted to mention that I think helps starts to bring this into view and understand why this is happening is just how camera sensors actually work, right? So we have these, basically you have a bunch of different sensors inside of this camera, and all they are tracking is how much light they are receiving in that moment on that pixel. It is as simple as that. It's not doing anything else. Each pixel is just figuring out how bright that spot needs to be. And so that is why using these different filters and things can be very useful.
By the way, I started a new image. That's why it went away. So otherwise,
It'll
if
start
I,
to build it up.
if I start to move, if I move to the blue filter in the middle of an image, it might smear it out. So that's why I started a new one. That's why you don't see it, but
And
it'll come up in a little bit.
Important to remember, this will still be a monochrome image, right? So we are using a grayscale camera to look through a blue filter. What this means is that the blue details will come out more, and the things that are more red will be less visible. And there you go, a great example, right?
Yeah.
So
So what I actually fibbed slightly. I said there was no filter. I actually have on the selection that I picked, it was a clear filter. So we were getting all the light, but it's at the same setting as the rest of the filters, so I wouldn't have to refocus the camera, because if I had no filter and then went to a filter, I'd have to refocus, and I didn't want to do that. So now you can see the M13 cluster and the blue light coming from the stars. It is very much, these are older stars. They give off less blue light, and so the image that you're seeing has less blue light. So I'm going to take a snapshot of this. I'm going to switch over to the green filter, and we'll see what that looks like.
yeah, so these globular clusters, right, they were formed a really long time ago. Many of the stars were formed around the same time period. And so that means that the hotter, faster burning blue stars have mostly died out in these clusters, and what is left is often these stars that lean more red in color, that have much longer lifespans. So you'll notice, when we had that blue filter on, there was a lot less you could see, right? And that was with all the same settings otherwise, I believe, right?
Yep,
Yeah.
all the same. Yep. So all I'm changing is the filter that the light is passing through. And then once we have all these three images, we can layer on post-processing, go into Photoshop, layer on a red wash, essentially, a green wash, a blue wash, put these together, and now we have a color image.
you get the true star colors
Right.
from that if you
Yep.
get it properly calibrated.
Yep.
Yeah, I will say with monochrome imaging, people say it takes longer. If you're doing like one night on one filter, the next night on another filter, the next night on another filter for a big image. However, you're getting a lot more detail, and it's going to be a high quality image at the end. However, if you're just out there, you want to get some great images, use a color camera. That's totally fine.
Folks have seen us use color cameras a lot at these
there's
shows
nothing
when we want to
wrong
have
with
those live views that are colorful, especially looking at objects that do have a lot of color present, things like these planetary nebulae, looking at planets like Jupiter as well. Also wanted to share an update. I guess this shouldn't surprise me. Bob's also waiting for a clear night to use his C-star in equatorial mode. He said maybe he'd do it later tonight. So, maybe you can come back to the chat comments tomorrow and see if he shared any updates, or I'm happy to share those at the next Sky Observers Hangout if somebody reminds me. Because actually I feel like I said the same thing at last Sky Observers Hangout, that I would share an update, and I have no idea what it was about anymore now thinking about it. So
yeah, I don't remember either.
You'll have to remind me at the next show.
I'll write it down.
But I'm sure we'll get an update from Bob eventually. So.
All right, 2 more seconds, and we get our next image, and of M13, and there it is in red.
Right, and definitely, it's, even just thinking back to the blue image, you can really see a big difference. But for folks watching online, if you want to switch back and forth between those, instantly going back on the playthrough, you can really, really notice how many more stars you can see in this field.
Yeah, it's almost as bright as the
clear filter, right?
Yeah.
Exactly. Very, very similar view, honestly.
Actually, if I switch to the images, I can flip through those if you
Oh
want
yeah.
to see that.
There you go. Sure, why not?
Go ahead. It'll take a minute.
Oh, okay, gotcha. Now, we've talked about some of the kind of introductory ways you can begin to get into astrophotography, right? Doing things with your phone, getting something like the C-Star that makes these processes a lot simpler. But we also did want to talk a little bit about some of the more complicated things that you can get to, right? Some of the more detailed work that you can do if you're really passionate about it and are excited about taking these incredible images, which there is a huge community for it. And so, do maybe a brief introduction into what kind of stuff goes into an astrophotography rig, how you can start to get into that, and how you take images.
Absolutely, sure. Yeah, I've set up my main rig back here, so I'll actually sneak back here to point out a few things. So this is a rather advanced telescope. This is called a RASA, R-A-S-A. It's made by Celestron. This is a RASA 8, and it's got an interesting design where the front of the telescope here, the light comes in this way, goes all the way to the back, bounces off a mirror, and then comes back to the front. Now, in a standard, what's called a Schmidt-Cassegrain design, it would then bounce off a smaller mirror, go all the way back down the tube, and go into the eyepiece or the sensor or the camera back here. This design doesn't do that. It has the camera right up front. It's actually sort of in the path of the light.
Right, you can actually see the more Schmidt-Cassegrain type with the observatory telescope
Precisely.
here, right? So the main mirror is back here, it's collecting light all the way up the front there, there's a secondary mirror in the front, and then it passes that back to the back. This is a corrected Dahl-Kirkham. It's a slight variation on the SCTs, but very similar style.
So what this allows is a much wider field of view. We saw the image before of the Andromeda Galaxy. That is 3 degrees on the diagonal, basically, in the sky, which is pretty darn big. If this light train were to continue to the back, and you can do imaging with Schmidt-Cassegrain style telescopes, it would be a much smaller part of the sky. It would also be what we call slower. So the ratio between the opening at the front and the focal length of the telescope, it would be a higher number. The ratio there would be like what we call F11 maybe. This is an F2. This can drink in a bunch of light and get a very quickly building up image using the camera here. What it also has up on top is a smaller telescope with an even tinier camera attached to the back. This is the guide camera. So what this telescope does is it looks where the main scope is looking, and through the computer that's attached to the back here, It finds part of the star field it's looking at, and then very carefully watches for that to drift at all. This is attached to a computerized mount, so it's tracking the sky as well as it can, but no mount is perfect, so there's going to be slight variations, and maybe the wind blows slightly, something like that. It's able to slightly nudge the scope back so that you get absolutely pinpoint stars. If the seeing is good enough and the tracking is working correctly, it works really well. On the back here, we have an automatic focuser, which it also is using the images that are coming from the telescope. It's taking a look, making sure the stars are as pinpoint as they can be. And then it's about every hour or so, it does another round of refocusing just to make sure it's not losing that focus as the temperature shifts, as the humidity shifts, and things like that. Even as the position of the telescope shifts, you can get a little bit of flexing there. It's a lot. I mean, this is a full astrophotography.
I was going to say, that is about, it's pretty close to as complicated as like at-home astrophotography rigs get.
Yeah.
This is typically the kind of, family of gear that a lot of people will have.
Absolutely. Now, you wouldn't need a telescope that big. You wouldn't necessarily need, you wouldn't even necessarily need a tracking computerized mount to begin with. You can actually start getting some pretty good images, even just using a DSLR, that you're able to take, even just on a standard tripod, you can take short enough exposures where the stars aren't going to trail at all, and you can stack those in a free stacking program and start getting amazing images of deep sky objects. You'd be amazed at what can be captured there. But this is, as you start getting deeper into the hobby, this is the kind of kind of purchase you might start to make. I will say the most expensive part of that is the mount. If you don't have a good mount, you're not really going to be able to do anything.
Right, it's essential for that
telescope in the world.
Because how long are you imaging when you're doing some of these pictures? Right, you're looking at one object for hours and hours.
Now it's shorter exposure, so it might be a 2-minute exposure. That's pretty standard. But that's 2 minutes where if the mount is jostling and going back and forth at all, you're going to get stars that are trailed. They're going to be smeared. It's not really going to look quite up to the quality that you're really hoping for. One note about the cameras. I don't know if we have a cooled camera on this one. Okay. So a lot of these are cooled. It's using something called a Peltier cooler on the chip. So I usually set mine at negative 15 degrees Celsius. So the chip itself is getting down to negative 15 degrees Celsius, which occasionally on the most coldest nights in winter, the fan doesn't have to run at all because it's already that cold. What that does is it takes down the noise a lot. There's much less noise on a cool sensor. It also makes it more sensitive to these very faint photons that are coming from these emitting areas of light, from these clouds of gas and dust that are out there in the galaxy. So every little bit helps, and so that's another thing. You don't need a cooled camera, but it can help a lot, especially with taking calibration frames and getting consistent temperatures in your images. It can really help a lot.
And that's really important to say is in order to calibrate your images properly, you want them all to be taken at the same temperature, not the same air temperature outside. The camera needs to be at the same temperature for each one. And so you need to know, okay, what is the temperature that you're actually taking all that at? And if you're gonna take more than one night's worth of images, you just have to match it and make sure you've got the same temperature each time. I do have the different colored images brought up. So I think you can hear me when I'm standing. Yep. So
we got blue right now.
That's blue. That's green.
Oh yeah, cool.
And that's red.
Look at that.
Yeah, so you can tell the green, that's letting in a lot of just the visible light spectrum, right? And you can see that and red are fairly similar, but blue does make a big difference there.
Yep, because those stars just don't give off as much blue light. The focus might be slightly off on the blue a little bit, but I'd say close enough. This is the first time we've done it with this, so.
Yeah, well, everybody saw us setting up while we were live. It's okay, they understand. We did get a question, is the Veil Nebula visible or is it too low? It is just now rising here, like literally right now. It's right up over the lake, just barely. So we won't be able to spot that tonight. That's a little bit more of a later in the year target. But good question. Now, I did want to talk about, we showed some of those filtered images, but I think you've mentioned a lot tonight about some of this narrowband imaging that you do. And one of my favorite pictures that you sent to us in advance of the show was some of the stuff of the Rosette Nebula that you had taken, showing some of these different channels that you get. And I think even more than M13, it really did a good job of exemplifying why we utilize these different filters and how different each different channel can look.
Yeah. So what you're seeing here, this is, it's usually not quite this messy on my processing software. This is a program called PixInsight. You don't need to dive in and buy a subscription key for PixInsight. It's a one-time lifetime key, but it's not cheap. There's plenty of free or nearly free processing software that you can use. This is very powerful. It can do a whole lot of cool stuff. But if you actually go back to the image before, so these are the images that went into the full final image of the Rosette Nebula. So I use filters. These are narrowband filters. So you hear astrophotographers talk about hydrogen and sulfur and oxygen. So out in space, there's a lot of dust and a lot of gas. And especially in star-forming region, there's also
Sounds like my house.
There's also very powerful, energetic stars. And these stars are blasting Hunter's house with all sorts of radiation. Light.
Fortunately, not a lot of radiation in my house. Yeah, not a lot of radiation.
And dust.
So something cool that happens in space is that, and also Earth, this gas and dust absorbs this energy from the radiation and then emits it at very specific wavelengths, depending on what the gas and dust is made out of. So if it's hydrogen, for instance, and hydrogen is all over in space, the rightmost image that you're looking at here is the hydrogen signal from the Rosette Nebula. There's just a ton of it, and it's emitting at, I think it's 656 nanometers. So it's a very red light. And the hydrogen nights are the best when I'm imaging in that. As we go across, the middle one is oxygen. You can tell there's a very specific area of that nebula that has a lot of oxygen in it, and not so much elsewhere. And that can tell us about the evolution of this nebula, kind of how it formed, what it's doing. And then on the left-hand side, you're looking at sulfur. So that's not always the weakest, but it often has kind of an interesting mix in with where the hydrogen is. So what does all that mean? Okay, so it's different colors. Both sulfur and hydrogen emit in very red wavelengths. It's hydrogen alpha and then S2. So it's very red. And then oxygen is kind of a bluish green. It's kind of a beautiful, beautiful color. And so that presents us with an issue, because we think about our brains kind of process colors as red, green, and blue. So it's like we got 2 red and 1 blue. If we put all that together, it doesn't look really good. So there's a few different ways that you can tell the software to integrate it. There's something called the Hubble palette. And the way I remember Hubble palette is it's HSO. RGB HSO. So we have, is that right? RGB. Oh, that's
yeah. So that means hydrogen is red, green is sulfur, blue is oxygen.
Yeah. So it's going to SHO. Sorry, it's SHO. HSO is a different way to combine it.
Whoops.
SHO. RGB. So we keep the sulfur red, we keep the oxygen kind of bluish green, but then we make the hydrogen, the strongest signal, match what our eyes see the strongest, which is green. And this is where you get those interesting blues and golds in some of the Hubble Space Telescope images, where they've decided on this particular palette to use, and you start to get that. So if you switch over to kind of the fully, so this processed image, you can see where you get the bright blue oxygen in the center, the hydrogen on the outside, and then this mixing of the hydrogen and the sulfur into this kind of gold color that's ringing there. Now this is not how it comes out immediately. You put these together, it looks a little bit more muted. You are doing some processing to really bring out some of the color that you want to see. That's part of the artwork that goes into it with astrophotography. It's not just pure data. That can be interesting, and obviously you can make amazing discoveries just with data. But by being able to process it and kind of bring out kind of your vision of how it might look, that's another way to do it. Another option is using just H and then 2 channels of oxygen. So for red, green, and blue, red would be the hydrogen in that case, and then oxygen would actually be both blue and green. And that can help you with some objects that don't have as much sulfur, number one, but also you're just looking for a different palette, different way to kind of bring out the character of the object.
But it really underscores a question that we get a lot, which is, if I were to go to this object, would it actually look like this? And the answer is no. No, it wouldn't. The structure, the object is there, but this is as much art as it is science. And so it's always going to be a representation of how it looks plus how you want it to look. Because if we stuck it with the actual wavelengths, and I've seen Hubble images where they'll give you a sample of what it would look like if we actually attached the real wavelengths to it. It just looks weird. It doesn't look natural. So whatever that means. So
I mean, it's almost the same way you take a picture on your phone and you go in and you want to tweak the settings or add a filter to it because it adds something. And I think sometimes people, when they learn that that's how astro imaging works, I often see this sentiment of like, oh, so it's not real. It's fake or whatever, right? And I think that that's a little bit more of an overreaction to what is really happening, which is just trying to bring out our ability to see more of these details, right? All of these things are very much real. They're very much there, right? You are imaging this stuff. It's not like you are adding additional light that wasn't collected originally, right? And so sometimes that can be a little frustrating where people think, oh no, that means that this is all fake, these Hubble images, like this stuff isn't really what it looks like out there. But it is very real, and these really are how these things are structured, and it's just giving us the ability to see those details better.
Yeah, I liken it to like a weather map if you're looking at the temperatures across the US coming up. Those temperatures aren't those colors, but it's giving you data, it's informing you about what the world will be like on those days in those regions. And that's the same thing that we're doing here. We're giving a particular color, we're kind of normalizing it so it's not just all red because there's so much hydrogen there. It really helps, I don't know, it's more information you can get from it. You can connect with it a little bit better if you're not quite faking it. But
no, it's not faking it. Those are all very real gas and dust clouds that are out there, you know, and you saw those individual frames. You can see how it all builds together. And I mean, getting to see views like this, I mean, how can you complain about that?
Right.
You know?
If anything, it makes it even more real. You're interacting with it. You are not just someone seeing a picture on the wall. You are working with this. You're working intimately with this object in the sky. So I think it's really, really remarkable that you can turn out results like this.
Yeah. Now we talked a little bit about the art side of astrophotography. Somebody had a question here, and they said a lot of astronomy requires math, right? That's a big part of astronomy and physics. Do you have to do much math with astrophotography? Any math come into play?
There's a little bit. Well, yeah, there's a little bit. If you were thinking about different F ratios. So this is an F2 telescope, it's very fast, versus a longer one. There's an inverse square law with how long it will actually take to get the same amount of data on that. So as you're maybe shopping for a telescope, thinking, well, how many clear skies do I actually have? How much time do I have to be outside?
Right, you were like, I gotta make it as quick as possible.
Exactly.
Doing it in Chicago.
Not many
100%,
and long time.
Yep.
Okay.
And also, figuring out your balance of your checkbook and everything. They're also in PixInsight, the processing software that I use. You can use vastly complicated equations that'll actually measure things in the image and adjust things variously. There's also a way to it's kind of amazing. It can identify what objects are stars in the image and take them out mathematically. And so you have an image of the stars and an image of the nebula or whatever you're imaging. You can process them separately and then recombine them. Or you might have a narrowband image with hydrogen, sulfur, and oxygen, and then you've got the RGB image of the stars, and you can put the RGB stars onto the narrowband image. So it looks a little bit more natural. The stars don't have kind of maybe a magenta or purplish tinge to them.
But when you got started in astrophotography, did you have to know all that before you even got
Nope,
started?
not at all.
Could you do all of this and not actually have to do the math right away?
Oh yeah, 100%.
There you go.
Hey, I mean,
You learn it along the way.
Yeah, we started talking about with
There you go.
just taking pictures with your phone, right?
Yep, exactly.
Well, I can tell you right now, I've never opened PixInsight in my life, so you can certainly get started without all of that
100%.
detail.
I need to move the roof again.
All right, no problem.
Just this way. 1, 2,
Bella said.
Okay.
Bella's of the opinion that that sounds like more than a little math.
Yeah, it depends how much math you want.
Well,
It's up to you.
I mean, it can get to be, but it doesn't have to be.
Yeah.
Yeah.
So a couple of other comments that we had coming in. One of them said, I'm just going to read this out verbatim. This does not all mean a lot to me. Maybe it'll mean more to you, Nick. AM3 with a WO Redcat 71, ZWO 533 MC Pro is all I need, and my C-Star.
That's great.
So they've got their setup for
yeah,
sure, too.
so the Redcat 71, that's fantastic. Williams Optics is WO. Fantastic telescope. It's a much smaller format than
It's a little
what you see behind me.
refractor, right?
It's
Is
like
that right?
slightly slower. Yeah, it's a refractor. It's beautiful, high quality glass in there. The AM3, that's a very cool type of drive, a mount that you have it. It's called strain wave. There's no counterweights as long as you're not overloading it. It's very smooth, very nice, and those are fantastic. 533 MC Pro, that's what I got right here. That is a great camera. It's actually kind of interesting. It's a square format. It's not rectangular. So it's actually really nice for like framing up something like a globular cluster, maybe the ring nebula, things like that that are sort of isolated. When you get things that are elongated, you tend to crop them out a little bit. But fantastic setup. I'm so glad you're able to image with that. It's great.
I know Geza gave a great response to this question, but I did want to bring it up because it does open up some interesting conversation about UV light. And can you buy a UV camera? Is that a thing the general public can buy for cheap? So this is a great question. There is imaging that is done in wavelengths beyond visible light, right? But a lot of that is happening outside of the bounds of the Earth's atmosphere. So the atmosphere is making it more difficult for UV light, for infrared light to reach the surface here, and that is why we are sending space telescopes out, right, is to get around that atmosphere. So we have space telescopes that are imaging in these different wavelengths, and that can reveal many new details of things that we haven't seen before. You may have seen some comparison images of Hubble with JWST and seeing how much more JWST is able to peer inside these nebulous clouds of dust and gas and see the young stars forming inside. So there are huge benefits to using those other wavelengths, but it can be tricky when you're stuck down here on the ground.
Yep.
All right, well, if anybody else has any other questions for us tonight, we've still got our lovely view of M13 here. And also, I mean, look at how much this image of the Pinwheel galaxy has built up over time. Really quite a bit different from, right, those faint fuzzies that we were seeing earlier. Now you're starting to actually be able to notice some of these spiral arms extending around the outside. I mean, Pinwheel is known for having those very distinct spiral arms that extend out of it. It's really face on the way that it's oriented for us here on Earth, and we're starting to get some of that detail. So seeing the benefits of that stacking, right? This has been going for about an hour. This also isn't perfect stacking, right? It's doing this all live, so it's not going to be exactly right, but you start to understand the benefits of taking many of those images, building that picture up over time and making it brighter and brighter.
Absolutely. Yeah, it's a great instrument to be able to do it. We'd mentioned earlier some ways of taking images, maybe of a little bit closer to home, like the International Space Station, or the moon and the sun. And those are things that you can do. You don't need a fancy setup like this. In fact, we got some images of the space station, one image in particular that I took crossing the face of the sun. And this is something you do need a good solar filter in order to protect not only your eyes, but also the camera equipment you're using. I was just taking a video on a DSLR, prime focus through the telescope, and then was able to combine those images, individual frames of the space station passing it. You can find, there's several places online actually, you can find out when the next transit either of the moon or of the sun will be of mainly the International Space Station. There's a few others that do that as well, and you can try it out. You can also, if you're up for a challenge, hand track with your telescope a nighttime pass of the space station and get images. Generally, you're going to be setting the DSLR to be automatically taking images at a certain interval. They have to be very short exposure. And then you're looking through the viewfinder, the smaller telescope on the side, and tracking and trying to keep the International Space Station in the center of your image.
If any of you saw me shaking my head and leaning back, it's because I'm just in shock.
Yeah,
this picture is insane. I cannot believe that.
And that's with the DSLR and the 8-inch Dobsonian or the Newtonian.
And people ask us here at the observatory, can we do the same thing? And the answer is, well, sort of.
Yeah.
The telescope is fast enough to keep up with the space station. The problem is the roof is not.
Right. So you may have seen some domed roof observatories that fully open to the night sky.
Yep.
Ours is a little different. If you visited, we just have a slot that opens up, and that's why we're spinning the roof around to keep things in sight, right?
Yep. The telescope can move up to 50 degrees a second, which is really fast. If you see it move here, it's only moving 8 degrees a second.
Yeah, I will say you'll find images of the space station online. Some people are able to program their mounts, even for just sort of amateur mounts, for the actual path that it's going to take, and they have very high quality filters and cameras, and they're able to catch an unbelievable amount. They can see which Soyuz spacecraft are attached to the space station.
That's crazy.
Yeah,
I was happy just to get the solar panels here.
I mean, it's
awesome.
I was just looking at it going, oh my God.
It's crazy.
But the other problem we have is you need to know its position extremely accurately, and our field of view is very small, and so we would need a wider field probably to have a better chance of getting it, because if we're off by even a little bit in terms of where the telescope has to point, we wouldn't be able to see it. So.
There's one more one I wanted to mention, kind of in between. The fairly simple with a smartphone. There's nothing wrong with that, but it's kind of point and shoot. And then the very advanced telescopes we see around us. If we go to kind of the squiggly-looking image, this is an interesting project. If you have a telescope and you have a DSLR, this is the star Sirius. And it's about an 8-second exposure, I want to say. And when Sirius is very low in the sky, so if it's just rising or just setting, you can aim your telescope at it with the DSLR at prime focus. And it actually helps if it's slightly out of focus. It's not perfectly in focus there. And then you set this 8-second exposure, and then you just kind of like drum your fingers or shake the mount a little bit, and you have Sirius trail its way across the sensor. And you can see the different colors that come out. This twinkling that you see, it often flashes brilliant colors in the sky. Oftentimes people think it's a UFO or something.
That's what I was going to say.
Sirius,
you see a lot of stories of people thinking
Yeah.
Sirius is a UFO because it is so bright, so brilliant, and it does. It feels like it's moving and
like
changing
a disco
in the
ball
sky.
or something. And here you can see trailed across the camera sensor all those different colors that are showing of Sirius. It's an interesting project, and each one turns out different.
I love that. Yeah, I love that as a little. So much of this can be art.
Another project we can do.
Yeah,
with this
you could do
telescope.
that.
Yeah,
It's a little.
yeah.
It's honestly a little
Very
trickier to get this to move around.
It
It's
actually
really
is.
very
It's
stable.
hard to move. You gotta kind of grab it and move it.
Yep.
So if anybody sees me in here going shaking the telescope like it's an art project, it's an art project.
So yeah, I mean, overall, there's no right way to do astrophotography. I would say there's no budget that you have to hit. There's no particular way to get into it. See what you're interested in, and kind of push yourself as far as you want to go.
Riffing off of defocusing Sirius a little bit, defocus any star,
Yeah.
and you can see the star's color really easily, and so especially the brighter ones. So we like to really crank the focus out out of focus for our telescope, and then take color pictures of the colors of the stars. And Betelgeuse, Rigel, the color just shows up in this nice little donut right where the star would be if you actually focused it. But it's really pretty, so, and easy to do because you don't have to focus anything. You want it to be unfocused. So.
All right. Well, this has been a great show, guys.
Yeah.
We've got, so ended up clearer than I expected, which I sorry if I sound like a broken record. I feel like I've said that every Sky Observers Hangout this year. It's been a rough winter for astronomy observing here in Chicago this season. And so we've lucked out a lot of times with Sky Observers Hangout. So keep sending the good luck our way, everybody.
Yeah.
We really appreciate it. Thanks so much for coming out. Just as a reminder, I know I mentioned it at the start, but I want to mention it now too. If you enjoyed the content tonight, make sure to subscribe to the Adler Planetarium below. You'll get notifications when future Sky Observers Hangout episodes are happening. And you can also see all the other great content that is getting put out on there. Some of the stuff that Nick makes, our other colleagues at the planetarium are making as well, from not only, tips for observing like we do here, but also comedy shows like Wow Signal and lots of things to check out. So subscribe down below if you're interested. Bella will also be posting a link to a feedback form. If you have any suggestions for how we can improve the show, any potential topics that you would be interested in us covering in the future. I know astrophotography is one that is frequently asked for in those feedback forms, and so I wanted to try and bring that to you today, give you those tips for looking up and taking your own pictures at home. So yeah, thanks so much for coming tonight. Any final words from you two?
This was fun. Thanks for holding down the seat here while I was finding object to actually look at. So that was really great. Thank you very much.
It's tremendous. Great to see these images coming in live. I mean,
Yeah.
I don't know, one of the joys of astrophotography, I think, is just seeing what's happening
And-
live on the camera.
And thank you for such awesome questions, everybody.
Really
This
great
was
questions.
Really great.
This has been a fun show for me too. I learned so much. Nick knows so much about astrophotography, and I was excited to do this show because I knew I would have lots of questions to ask as well. So
We've only been talking about doing this since we installed the
been a while,
telescope,
yeah.
pretty much. So yeah, this is
Made it
really
happen.
great.
all right, well, thank you all so much for joining. I hope that you guys get the chance to go out and take some astro photographs of your own tonight or soon. And if you do, send them to us on social media. Use the hashtag #lookup. We love seeing the views that you're getting. So much of Sky Observers Hangout is that hangout part, right? It's all about us. It's about the community of observing. We love observing and showing you the views that we have, but we also love seeing the views that you guys are getting at home too.
And please include your screen handle to make sure if you want to share us a picture, we might use it in a future.
That's true.
Sky
That's true.
Observers
You
Hangout.
can maybe get your astrophotograph in these slides.
You never know.
And Bob, let us know how the EQ mount testing goes with the Sea Star. Hope it goes well. Well, thank you all so much for joining tonight. Have a wonderful rest of your night, everybody.
Good night.